Hi, today I'm going to show you a new language called Effekt. It's interesting to me because it is based on the idea of algebraic effects and handlers. I'm going to explain what this means very quickly and how programs written in languages like this one would look like and why it might be interesting for you if you're a functional developer. So let's get to it. Just like in every other language, the most basic program we can write is Hello World. Now, this is as simple as it gets. We cannot write any simple program. This is just a main with no effects and anything else in it. But that's not a hello world yet because we haven't even printed anything out. So let's do that. Now, you might have thought that this was all it took to implement this, but that's not. Because now, suddenly, we have an unhandled effect called console. And we, as developers, aren't really able to handle that effect on our own. We need to ask the runtime to do it for us. So I'm going to do just that. And it turns out that the only thing I have to do in this particular case is to mention in the type signature that this function uses the console effect. So let's do that. Now I added this and suddenly the program compiles. So let's run it. And that worked. So here we only caused an effect, but we didn't handle it. We let the runtime do that for us. So let's create our own effect. So mine is going to be called print hello. It's just going to do the same thing except in a slightly different way. Now I have an effect that when I cause it, I will get a value of type unit, but it might cause some effects in the meantime. So let's try to use it in some function. So I mentioned the print hello effect in the signature because I know that I will be using it and I won't be handling it in this function. I will handle it somewhere else. So I need to keep it in the signature, otherwise the program would just not compile. So instead of saying print line hello world, I'll be able to do the same thing except by causing an effect like this. And I can do it as many times as I want. So let's leave it at 3. And now let's try to call this function. So now I'm going to write another function that will handle the effect. Now if I just call the demo function, my demo handled function will also have the effect of print hello, because I did not handle it, and the type inference in the compiler allowed me to see this immediately. Now I can still run it and I can still handle this. So the way we do it is we try, just like you would try an expression in Scala or a statement, that might throw an exception. But in this case, instead of handling exceptions, we will be handling effects. So I can try with, and now I have to mention the effect that I want to handle. In this case, it's print hello. And the syntax looks like this. In here, in this block, I get to say how I want this effect to be handled. Like, do I want to throw an exception? Do I want to print something? Do I want to write a file? And I can do anything I want. And I get 2 choices on what to do afterwards. But let's first do something. So in here, I'm going to print. I'm going to do the exact same thing we did in the main function. And that's it. So let's see how the type signature changed. Now demo handled only has effects of type console because I handled all the print hello effects and replaced them with print lines. Now let's try to call that. And it compiles. Let's run it. Now what might be surprising for you is that we only saw one hello world on the screen, but we actually called it 3 times. So what happened? It turns out that this try with, in this case, this behaves pretty much like an exception and an exception handler, because we caused one effect, then our handler sort of caught that and replaced this do with a print line and then exited from the function. Now we can still continue to the next print hello if we use something called resume. So instead of just exiting from this handler, I can resume with a value. And in this case, my value will have to be of type unit, because that's the type of the do expression used with this effect. So here, when I resume, I have to resume with a unit. So that's what I am doing now. And let's see how the code behaves now. So now we print 3 times. Now, this is quite new because unlike with exceptions, we can actually continue inside our function. So when we actually throw something, in this case we do something, that doesn't mean it's the end of the world. The function may still continue if the handler provides a value to be inserted instead of this do expression. So if we go back to the example of exceptions, we might have an exception like an exception for numbers that will be able to provide a default value. Let's try to use that. So I'm going to define a different effect. It's going to be a number exception. It's going to take a message and it's going to return an int. Now I can actually pass a program that has certain effects to a function and let that function handle these effects so that I'll be able to pass a program with effects and get a program with other effects, or maybe with no effects if we can handle them locally. So let's do that. I'm going to write a function that takes a block of code that can potentially throw these number exceptions and gets rid of them. So let's do that. So you may be wondering why I use braces in that signature. This basically means that I'm passing a function, like a block, and not just a value. These have slightly different evaluation semantics, and I don't want to dive into that too much. You can read up on it on the website of the language. We can still do things like map on a list, but we cannot say just like map f, because we cannot convert the function to a value. So now I can try handling this. So let me try that. And now after trying it, I need to handle it. And now the block of handling becomes much more interesting because it's actually like a function. Here, I will get a message and I get to do something with it. So in this case, I'm going to print it. And now I got a compilation error because I didn't actually execute this program that I was given. I just treated it as a value, which it's not. It's actually a function that needs to be applied. And now I have the effect. I did handle my exception by printing something, but I still need to do something that will result in the t value because that's what I expect in my whole program. And the only way that I can get a t is if I allow my program to do the rest of what it needs to do, because it's a program that is supposed to finish with a t, and I don't have one, but I can allow the program to continue with some value. And I know what kind of value it is because it's going to be an int. That's the only thing that the program can expect in a place where it does a number exception. So I'm going to resume with a default value of 0. And now everything compiles, but we still haven't even written the program that would use this effect. So let's do that. So it's going to take a number. And if the number is greater than 1, we will want to use it. But if it's not, we will want to raise the exception and just do that. So what I'm going to do is I'm going to check that. And in this case, I'm going to return n. But otherwise, in the else case, I will do number exception not greater than 1. And this compiles. So again, what's going on is the do expression takes a type of the return type of the effect. You can think of it as something like that. So whenever you do a number exception, this will be an int. And the only way that this int can be provided is if we resume from the handler. But if we don't resume, then the whole number demo function will just stop at that exact place. And that will be it for that function. But this also means that we won't get a t in this generic handler. So in order to get a t, we need to run resume. We need to run the rest of the function afterwards. So let's try to run this code. So I'm going to call number demo with a number like 2, and I'm going to print that. But I have an unhandled defect, so I need to handle that using handler number exceptions. And I need to use braces, and here we go. So let's run that. And that just returned 2 and printed 2 because that's what I passed, and my number demo program just returned that. But if I pass something else, like a 1, now I would expect to see handling number exception with a message, like not greater than 1, and then the returned value will be 0. So that's what happened. Now, What would happen if we used resume more than once? Now this is interesting. We printed 0 twice because our print line was part of the program that we were handling effects in. So when we said resume for the first time, we replaced this do with a 0 and returned to the print line, and that was printed. But then we resumed again, and that also resulted in the do being replaced with a 0, and we also print lined again. Now, what if the print line was not part of our program here? Well, now our resume only worked once because we returned a value from number demo, and then that was handled and that was printed, and that's it. We cannot resume again because there were no more effects to be run after the do expression. So there's much more we can do with this idea of algebraic effects and handlers. We can define effects that correspond to known monads from functional programming, such as the state monad, the reader monad, all sorts of stuff. And we can quite easily implement the logic in them, but in a completely different style. Because we aren't using any flat maps, we aren't using for comprehensions, we aren't using async await. We are just using statement-based programming, something very imperative and not very functional. We cannot even pass a program as a value, so that's breaking referential transparency in many ways, but it still gives us a lot of power, and it's a quite new approach to writing programs with effects. So I'm excited to see what it grows into. So that was a quick introduction to algebraic effects and handlers. Check out the language, check out the website. You can try out the compiler and the runtime already. So please do, it's really nice, it's pretty cool, and it looks like Scala a lot, so I liked it. There's many more languages using the same ideas, but in a slightly different way. So I encourage you to check that out as well. Just play with it, let me know what you think, let the authors know what you think. Just don't forget that it's a research language, and as such, it's not going to be production ready for a while, if it ever is production ready. It's meant to be a playground for new ideas, new ways to write code, and as such, it might not turn out to be good. But so far, I'm pretty hooked. I'm not going to use it for anything serious, but it's pretty cool to play with. So I recommend that you check it out and let me know what you think. So thanks for watching, and I'll see you in the next episode.